Hello friends, myself Sanjay Raj. Now I'm going to explore about breadth first search algorithm. Before that, let's seek into the basic concepts to understand better. Now let's see about the graph and its definitions. What is graph? A graph is a data structure that consists of a set of vertices and a set of edges that connect pairs of vertices. Main concepts in a graph are vertex and edges. Vertex is a node. Edges are the connections between pairs of vertices. Edges can be directed or undirected. There are four types of graphs. Let's see that now. So basic four concepts are directed graph, undirected graph, weighted graph and unweighted graph. We can search the elements in the graph by two methods. They are BFS and DFS. Now, let's seek into a concept breadth first search algorithm. What is meant by BFS? BFS is nothing but breadth first search, a fundamental graph traversal algorithm. It involves visiting all connected nodes one by one. The relationship between BFS for graph and BFS for tree. The only catch here is that unlike trees, graphs may contain cycles, so we may come to the same node again. BFS uses a queue data structure for traversal. Starting from the root, all the nodes at a particular level are visited first, and then the nodes of the second level are traversed till all nodes are visited. Let's explore the working of BFS. BFS first 1, 2, 3, 4, 5, 6, 7. Now let's have see this example. First it starts from 3, 5, 8, 25, 1, 2, 12, 8, 6, 4 and 9. So this is how the BFS and DFS is used. Now let's see the BFS pseudocode for proper understanding. Pseudocode of BFS. This is the pseudocode which implies the algorithm used in BFS. You have to create an empty queue, enqueue the start into the queue, create an empty visited set, add to the visited set. While the queue is not empty, dequeue from vertex v, and finally add it to the visited set. Now let me explain the pseudocode. Now let me explain the pseudocode of breadth first search. First, initialization. Create an empty queue. Mark the starting vertex as visited and enqueue it to queue. Second step, while loop. While queue is not empty, dequeue a vertex v from queue. Third step, process vertex. Process vertex v, example print it or perform some operations. Fourth step, explore the neighbors. For each unvisited neighbor u of vertex v, mark u as visited, enqueue u to queue. Fifth, termination. Repeat step 2 to 4 until the queue is empty. Let's write the code for BFS in Python. So this is a sample code which is written in Python for BFS algorithm. Time complexity of BFS algorithm, order of V plus V. Space complexity of BFS algorithm is order of V. BFS uses a queue to keep track of the vertices and that need to be visited. In worst case, the queue can contain all the vertices in the graph. Applications of BFS: shortest path in animated graph, finding graph connectivity components, cycle detection in undirected graphs, bipartners testing of graph, level or traversal in tree. Now, that's all. This is about BFS algorithm and traversal. Thank you.